Wasat Center is one of the centers established in May 1955. The center acquired 139 hectares farm along the right bank of River Mahi, which is representative of the problem of the area, in 1956. Subsequently, the administrative control of the center was transferred to the Indian Council of Agricultural Research on 1st October 1967. R&D activities of the center focused on evolving strategies of soil and water conservation on watershed basis, tackling special problems of ravine reclamation. A complete package of practices has been developed for protection of ravines while putting it to productive utilization. Popularization of watershed management concept and technologies, strategies for groundwater recharge and management, demonstration of technology and imparting training are important activities of the center. The 120 countries have committed to set the UNCCD United Nations Convention to Combat Desertification Sustainable Development Goal on achieving the land degradation neutrality by 2030, including India. The target has to be accomplished in a synergistic and cost-effective manner in accordance with countries' specific national contexts and development priorities. Globally, the ravine landscapes are considered among the world's most degraded ecosystems. Therefore, restoring ravines is considered a high priority item in the natural resource management programs. The vegetation cover, augmented with appropriate soil and water conservation measures, is the most sought restoration strategy. The study was conducted on a semi-arid degraded ravine landscape located at Wasat, district Anand, Gujarat in western India. The regional climate is a tropical semi-arid dry type with an average annual temperature of 25 degrees Celsius and average rainfall of 871 millimeters per year. Around 90% of the annual rainfall is received during the monsoon period, July to September. The area experienced drought 475 millimeters in 2015 and high rainfall 1611 millimeters in 2013, respectively. The native vegetation consisted of typical tropical dry deciduous and thorny species of Acacia, Prosopis, Lantana shrub and the annuals. The soil is classified as fine, loamy, mixed calcareous, hypothermic and falls under fluviatic osteocrasts. In general, soils are low in organic carbon 0.5% and nitrogen 96 kilograms per hectare, and the soil pH value is around 8.0. The study was initiated in 2010 to assess the potential of soil and water conservation measures (SWCM) in the restoration of degraded ravine lands. The experiment results were recorded for 12 years, 2010 till 2022.
I am Dr. Dinesh Chingar, working as a scientist in this institute. I have been associated with this project for the last 3 years, and I am dealing with the agronomical aspects of the crops and the fruit trees taken up in this project. Actually, we have taken three kind of the different land use system in this project. The number one is the sole cropping of cowpea and castor. The second one is the agroforestry system of castor, cowpea and sapota, and lastly is the sole planting of sapota.
Initially, the experimental site was cleared by removing scattered vegetation and thorny bushes to ensure plot uniformity and to design conservation measures for developing the production systems. 4 plots, 72 meters length times 24 meters width, parallel to the slope, were established at the experimental site, each separated by an earthen bund 30 centimeters height. 2 plots were converted to terraced land and divided into 4 subplots terrace to reduce slope length for soil water conservation.
I am Dr. Gaurav Singh, working as a scientist in Land and Water Management Engineering at ICAR Indian Institute of Soil and Water Conservation Research Center, Vasad, Anand district, Gujarat. I have been associated with this project since I have joined this institute in year 2016, since I have been looking after the hydrological aspects of this project. This project is a flagship project which deals with the reclamation of ravine lands and its productive utilization in the western India. Especially it is located in the Mahi bank or right bank of Mahi river in the Gujarat. So in this project we have taken total 5 different treatments. In the first treatment we have converted this ravine slope, which is about 16% slope. So we have converted the slopes into terraces, and we have then taken the agroforestry system based on the Sapota. So in the agroforestry system we have converted this land into terraced land, and total there are we have the experimental plot is of 72 meter by 24 meter. So there are 3 terraces in this experiment, and similarly the slope is also converted along with Sapota plantation with trenches. So the first treatment, if we see, it is the slope which we have planted with Sapota along with the terraces, Sapota along with the trenching. The second treatment is the terraces plantation with Sapota, and the third treatment is the Sapota plantation on the bench terraces with castor and cowpea, and the fourth treatment, it is the plantation of this castor and cowpea alone on the bench terraces, and the other one is the slope land which is we have taken as control.
The remaining 2 plots were maintained at a uniform slope, 14% for designing trench and control treatment. In one sloping plot, 96 trenches sized 2 times 0.5 times 0.5 meters were designed as soil and water conservation measure, while the second sloping plot was maintained as a control. In this experiment, bench terracing and sloping designs were considered, keeping in mind the regional geography, as bench terraces and slopes are common throughout the entire ravine landscape. Trenches were considered to observe their effectiveness in intercepting runoff and water storage for plant growth. Trenching also needs very low soil disturbance compared to bench terracing. The 4 treatments undertaken in this study were as follows: bench terracing plus Sapota BT, bench terracing plus Sapota with crop cultivation BtCr, continuous slope plus Sapota SL, continuous slope plus Sapota with trenches SLTR, control continuous slope with any conservation measures by plantation. In March 2010, 6-month-old seedling of Sapota were planted in all of the 4 treatments in uniform number, 27 in each treatment at spacing of 8 meters times 8 meters. The recommended cultural practices were followed to maintain Sapota growth and productivity. In Sapota, with crop cultivation treatment, castor and cowpea crops were grown along with Sapota to observe the effect of crop cultivation and tillage on soil loss and tree growth. The crops were grown annually in 1 castor is to 2 cowpea proportions, and conventional tillage and standard recommended agronomic practices were followed. A V-notch iron structure and stage level recorder was fixed at the outlet of each plot to measure soil loss and runoff respectively. The mean annual runoff was recorded higher in continuous slope plus Sapota SL, followed by continuous slope plus Sapota with trenches SLTR, and bench terracing plus Sapota with crop cultivation BtCr compared to bench terracing plus Sapota BT respectively. Similarly, the soil loss was recorded greater in bench terracing plus Sapota with crop cultivation BtCr followed by continuous slope plus Sapota SL and continuous slope plus Sapota with trenches SLTR compared to bench terracing plus Sapota BT. Quantitatively, bench terracing and trenching reduced mean annual runoff by 1060 and 520 meter cube per hectare per year respectively, while soil loss was reduced by 1.5 and 0.90 megagram per hectare per year respectively, compared to the continuous slope SL. In contrast, bench terracing with crop cultivation produced 1.01 megagrams per hectare per year higher soil loss and 850 meter cube per hectare per year lower runoff compared to the continuous slope. The results showed that conservation measures, bench terracing and bench trenching reduced the runoff and soil loss in degraded ravine lands. The mean tree height and collar diameter in BT, bench terracing plus Sapota, and BtCr, bench terracing plus Sapota with crop cultivation, SLTR, continuous slope plus Sapota with trenches, and SL, continuous slope plus Sapota treatments ranged between 246 to 379 centimeters and 8.0 to 10.9 centimeters respectively. Height and diameter growth showed maximum increase in BT compared to SLTR, BtCr and SL. Tree height in SLTR, BtCr and SL treatments were recorded 12.4%, 17.7% and 35% lower respectively compared to BT. Likewise, compared to BT, that is bench terracing plus Sapota, diameter growth was observed lesser in SLTR, that is continuous slope plus Sapota with trenches, 9.8%, BtCr, that is bench terracing plus Sapota with crop cultivation, 13.4%, and SL, that is continuous slope plus Sapota, 26.4%. Overall, conservation measures such as bench terracing with crop cultivation and trenching improved height and diameter growth in Sapota compared to continuous slope. Moreover, crown area and canopy cover also portrayed more or less the same picture as height and diameter growth in all the treatments. These results showed that conservation measures enhance the height and diameter growth of Sapota. Destructive sampling of 25 branches of varying diameters greater than 2.5 cm was carried out to determine dry biomass, leaf plus branch biomass in the Sapota tree.
Myself, Dr. D. Dinesh. I am working as a soil scientist for ICAR Indian Institute of Soil and Water Conservation Research Center, Vasad, in Anand district, Gujarat. I was involved in this project from 2016 onwards. In this Sapota project, we are having 5 treatments. Among the 5 treatments, it is very well noticed that soil biomass carbon and soil carbon stock is higherly recorded in our agroforest system compared to control. Whereas if you look the quality aspect of the other treatment, it is very well proven that the agroforest system, it is maintaining the very good quality of the soil even after 10 years of cultivation also. Because of this consistency in the soil quality, we are strongly recommending this agroforest system for these ravine affected lands to promote the agriculture along with the forest system. Here again we are noticing from this experiment, due to soil loss, the crop growth is severely affected in the tree system alone, control sloping system alone. They are observing continuously declining the soil organic carbon, nitrogen, nutrient status, and the plant growth also severely affected because of the soil erosion. It is very well proven from this experiment.
In order to analyze the soil physics, chemical properties, a composite soil sample was made from 4 sub-samples which were collected at 3 different depths: 0 to 15, 15 to 30, and 30 to 45 centimeters for each treatment. The soil pH and EC were determined using 1:2.5 soil to water suspension with a multimeter. The organic carbon was determined using wet digestion method. The available nitrogen, phosphorus and potassium were determined by alkaline permanganate, SnCl2, reduced phosphoromolybdate and flame photometer methods respectively. The soil and water conservation measures significantly affected biomass and carbon stock of Sapota. Bench terracing BT improved biomass and carbon stock by 4.4 and 2.2 trillions per hectare respectively. Compared to the continuous slope SL, while trenching SLTR had 2.9 and 1.5 trillions per hectare increase respectively. Similarly, cultivated bench terrace BtCr recorded 2.3 and 1.2 tons per hectare higher biomass and carbon stock respectively compared to the continuous slope SL.
मैं आनंद कुमार, तकनीकी अधिकारी, भारतीय कृषि अनुसंधान परिषद, भारतीय मृदा जल संरक्षण अनुसंधान केंद्र वासद। इस सपोटा प्रोजेक्ट एक्सपेरिमेंट में 5 ट्रीटमेंट हैं, जिसमें प्रत्येक ट्रीटमेंट में गेजिंग स्ट्रक्चर है। गेजिंग स्ट्रक्चर की सहायता से वाटर वॉल्यूम और सॉइल लॉस मेजर करते हैं, जिसमें स्टेज लेवल रिकॉर्डर इंस्टॉलेशन होता है और बी नोच की सहायता से पानी की एक डेप्थ कैलकुलेट करते हैं, जिसमें हमारे को पता चलता है प्रत्येक ट्रीटमेंट में कितना वाटर आया है और कितना सॉइल लॉस आया है। इसकी सहायता से हमारे को क्लियरिटी आती है कि कितना अकॉर्डिंग टू रेनफॉल के द्वारा हम कितना इसमें जो टेक्नोलॉजी को डेवलप कर रहे हैं उसकी सहायता से हमें क्लियरिटी आएगी कि प्लांट ग्रोथ और क्रॉप ग्रोथ का सही से ऑब्जर्वेशन लिया जाता है।
Overall, biomass production and carbon stock was observed higher in bench terracing, followed by trenching, cultivated bench terrace, and least on continuous slope, respectively. These results explained that conservation measures improved the biomass productions and carbon stock in Sapota. In this study, nitrogen N, phosphorus P, and potassium K in BtCr cultivated bench terrace were recorded significantly higher compared to BT bench terracing, SLTR trenching, and SL continuous slope. However, a comparison among BT, SLTR, and SL revealed that organic C, N, P, and K were highest in BT, followed by SLTR and least in SL. Change in soil physic-chemical properties showed the maximum change in soil N plus 48.2%, P plus 55.1%, and K plus 27.5% in bench terracing with crop cultivation. On the other hand, the least change in soil N 15.1%, P 0.3%, and K 7.3% was recorded in the continuous slope. Increase in organic carbon was recorded highest in bench terracing 21.5%, and a decrease was recorded in bench terracing with crop cultivation negative 13.4%. Compared to the continuous slope, these results support the notion that conservation measures improved the soil properties in degraded ravine lands. Crop yields was recorded quite variable during different years as a consequence of drought, high, heavy, and abnormal rainfall events during the experiment period. Although Satisfactory cowpea and castor yield was recorded during normal rainfall in these semi-arid conditions. Change in rainfall pattern during a particular year significantly reduced yield of both the crops. The cowpea was observed to be highly sensitive to the change in seasonal rainfall compared to the castor. During the study period, 2015 was a drought year and BT had the highest fruit yield, which was followed by BtCr, SLTR and SL in decreasing order. In general, bench terracing BT, bench terracing with crop cultivation BtCr and trenching SLTR had 604, 434 and 69 kilograms per hectare more fruit production over continuous slope SL under drought conditions. These results demonstrated that conservation measures sustained fruit yield of Sapota during the drought period. The results of this study indicated that bench terracing is the best conservation measure for the rehabilitation of ravine lands of Western India and trenching is the second best option. The choice between the bench terracing and trenching is a matter of options available in terms of financial implications and landscape accessibility to heavy earth moving machinery. Bench terracing and trenching brought in significant decrease in runoff 34 and 16% respectively and soil erosion 25 and 15% respectively and enhanced tree growth, biomass and carbon stock. Crop cultivation in between tree plantations may induce significant soil loss 18% higher even though runoff is not significantly affected. Crop cultivation may be an important means to compensate for cost of land modification, yet it needs to be carefully evaluated. Conservation measures like residue retention, mulching and raised dikes need to be implemented when crop cultivation is adopted. In case bench terracing itself is not feasible, then trenching in between the tree rows and oriented perpendicular to slope would serve significant purpose for rehabilitation of highly degraded ravines. These conservation measures could also be important strategies for climate change mitigation and adaptation for such highly degraded and marginally productive regions of the world, where slight improvements can have substantial impact on the environment as well as society.
सपनों की छाँव में मेरे गांव के बढ़ते जाएं कदम, लहराए फसल हुंकार भरे जब खेत में टफ हरदम। सपनों की छाँव में मेरे गांव के बढ़ते जाएं कदम, लहराए फसल